Hello, can everyone hear me okay? Good stuff. Hi everyone. Jamie here. Thanks, Alec. It's great to see you about 5 minutes of my presentation. So, just get my notes up here. So, yeah, it's great to be back here. This is my spiritual and commercial and everything home. I've said it loads of times in this particular application, so it's really nice to be back here, and especially after such a long break. I think last time I was here was maybe 5 or 6 years ago for a conference, and this is my first presentation post-COVID, so apologies if I'm incredibly rusty. So today we're going to talk a bit about potentially shifting left with confidence. There's meant to be a title slide there, but it's disappeared. But that's all good. So what are we going to talk about? We're going to talk about what is shift left. So it's a fairly new topic. There's some fairly new ideas here, but I'm sure a lot of you probably heard of some of the theories and some of the applications that can be used on them. What is shift left? Great, we love shift left. How do we go about doing it? And I want to share some of our experiences that some of our customers have had, sort of trying to implement some of the shift left capabilities. But before I go there, so Matt gave a really good overview of my background, my history, and so I've got quite a lot of experience building and selling cybersecurity products. And predominantly the products I've sold in the past have been post-breach, or they've been about protecting things once things have gone wrong. And that's great. It's a really interesting part of the industry, really interesting part of the sector. But over my career of selling these solutions with the various companies I've worked for, I've always thought about how can we prevent these things from happening in the first place. And there's a really startling statistic about how many security breaches are due to insecure or poor quality software. I think something like 76%. So the idea of improving the quality or the security of software before it's released is really core to me. It's something that I truly believe in terms of the work I'm doing with Lesco, but also some of the other startups that I work with as well. So finding security vulnerabilities before software released is a big part of what motivates me right now. And I think in terms of where we're going as an industry, we need to be a big part of what we consider helping organizations, as we'll see, shift left. So what is shift left? So does anyone know where this is? I've been there. It's really nice. Anyone know? It's in Iceland. It's great. I saw it and it wasn't quite as literally that as musical, but it's great. You can get in behind it. It's great. And this is an ancient waterfall, and it's also an ancient way of developing software. But some of us still do it. Who here still does waterfall software development? Good for you. Good for you, Malik. Thank you for bringing that in. So we've all moved to Agile, right? We're all completely Agile. We don't do any kind of waterfall. Yeah, thank you, Doug. So good. Glad we're in the presence of very modern software development practitioners. So this is how we've developed software in the past. So we start with projects, you come up with a plan and develop it and release it, and everything's perfect when you release it. Great. So it's not quite the case. We did go towards agile software development, where we have the ideal sprints, and we have small-sized chunks of developing software. We can change things on the fly. We're not committed to a course of action. And really, this is where the world of testing has started to catch up to as well, where we have the traditional model of testing, which happens at the very end. So maybe in the release pipeline, you do some form of unit testing, you do some form of integration testing, so on and so forth. Security testing is typically relegated to the very, very last part of the deployment process, if it was considered at all. And in this conversation, we're going to be talking about security testing, and I'll be just talking about testing in general, and not things like unit testing, which are pretty well-known quantities and fairly well understood when it comes to that development and deployment piece. So shift left is about trying to anticipate problems, quality issues, vulnerabilities which may occur from software development, from architectural issues earlier on in the process. And so shift left is about putting it further up so we can anticipate and address these problems a lot earlier. So why do we want to shift left? So Dave gave some really good insights into why we want to do this. So sometimes you have to do it. Sometimes the regulations say you super need to tell us about the quality of the software that you're developing and deploying. So we've got a customer in Germany, for example, who have to meet the battery regulations, which are really interesting. So they ask you to take a risk-based approach. We just had a really interesting conversation with risk, how you quantify that. It's non-prescriptive, so it's up to you to figure out how to do it. So you've got to report to the regulator. So that's one of the reasons why one of our financial services clients in Germany is using our product, because it provides them with an insight into the quality of product that they're releasing to customers. It gives them an insight into the risk they have across their software portfolio. They also have to report to their customers as well. And quite a few of our clients have this use case where on their roadmap and on their release plan, they need to inform their customers the kind of vulnerabilities that are being found, the reasons why they have been fixed, or, really importantly, why they haven't been fixed. As we'll see later on in this presentation, not all vulnerabilities do get fixed, and that's fine within certain parameters and certain ways of working. And I think this is one of the really important things that I've certainly learned from my journey to application security, which is, originally I thought, as Unbox, we release the software, we find vulnerabilities, and I think, this is terrible. Our business is going to go under. No one will buy this piece of software because we found this big hole in it. However, not all vulnerabilities are the same. Different contexts, different environments are important to consider before we fix something. And often, it's a negotiation or a conversation between security and the development team. It can be a very angry conversation at times, sometimes slightly violent, but we get there in the end. Another reason to do this is it can save you time. It's often a lot easier to fix something before it goes into production. I'm sure you all know. Who likes fixing things in production? Yeah. It can save you reputational damage, so we've had that conversation already. You gave us a fantastic presentation. Thank you. But most importantly, it can save you money. And this is sometimes the bottom line. This is sometimes the conversation you want to have with various stakeholders. So at the top, it's a Ponemon Institute study, a defect that is removed after the product has gone, a defect that's been removed after the product has gone into product will cost around 100 times more than one that's identified or removed during the requirements phase. There are variations on this, but there's a multiplier there. It's a lot more expensive to fix it later. Fixing software, once it's been released, costs in the US $1.3 trillion. Imagine how much it costs to patch these systems, to get them out, get them up and running. So money is a great motivator for fixing things. Great, I'm sold. How do I shift left? So this is typically the process we recommend. We see a lot of people go through. This is not hard and fast, but these are some of the things you definitely want to consider and address. So I'm just going to go over them fairly quickly and join them some of the insights we've had from some of our customers. So first of all, address culture. So why are you doing this? What's driving this? It's often not enough for the security team to say, okay, we sorted our firewalls, our passwords are all secure, let's tackle application security next. Typically, we need support from the entire organization, and we'll see why in a couple of slides, based on some of the cultural factors. Assess your development process and stakeholders. We will see a maturity slide, which will give you an insight into where it can be slightly easier to implement testing, where it can be slightly easier to automate some of these things. So it's about the kind of process you've got there, and also how your teams interact with each other. Who are the key stakeholders? How are they motivated? How are they tasked? And how are they compensated in their day-to-day jobs? Train development teams in secure coding. It's not just about secure coding, as you'll see. And then we work on some tools to give us some insights. You can't manage what you don't measure. So you need some way of getting metrics out of your system in order to get those insights. And then finally, we highly recommend automating it. But disclaimer, I work for an automation company, so take that with a pinch of salt. So let's talk about culture, and let's talk about development process and stakeholders. Sometimes we find all three of these particular players within the company. teams. Sometimes you just get one, which is the development team. Sometimes you get two, security teams and development teams. But typically you're trying to get 3 teams of people who typically have slightly differing objectives trying to work together to fix a problem. And the problem is security of the product. So security teams are typically motivated to secure things. So they need to take a risk-based approach, typically. They've been tasked with understanding the level of risk within a product or a system. They need to get information about whether those things have been fixed, whether they're present, whether there's any plans to fix them. And if not, they need to keep that in a risk register. And they need to report on this to their various key stakeholders that they report into, from say, the board level, for example. Then you have development teams. Development teams are typically tasked to get features out the door quickly and efficiently, and in a state that allows them to be used by customers. So they have the requirement for things to be functional, but maybe not necessarily secure. So already you have a bit of a tension between the security teams, who would like, and I'm going to say something controversial here, I think I'm on about it afterwards, but we're talking about quality kind of assessments. We want this thing to be of a certain quality adhered to from a security team perspective, versus the development team's idea of quality, which may just be it works. And sorry. And then we've got DevOps teams. We've got DevOps teams who are kind of stuck in the middle. We find that these teams sometimes work across both functions. We work with security teams where DevOps is associated with them because they help them automate and run a lot of processes within the organization. Or you have DevOps teams that work closely with development teams, or are the development team. The idea of fully integrated DevOps into the development team is kind of a holy grail, right? And their goal is, I need to support the team with automation, secure app development, and also release pipelines, and all the other things that need to happen in order to make sure that when you hit commit, your code gets tested, run, spat out into production in as efficient a manner as possible. Or stopped, if that's the case. You just stop the build sometimes. So you've got these 3 computing kind of people within this particular relationship. It's very complex. Often what we see is that people like to throw things over the wall. It's not really a conversation. We have devs are from Mars, security people are from Venus, or maybe it should be the other way around, I'm not sure. But you have to fix a thing as a team. But the way in which we've configured our organizations means we're not really working as a team. We're having many parallel conversations. Maybe we're talking at each other, not with each other. So from a development perspective, and both of these are completely fine and perfectly normal attitudes to have, by the way. This is not one team trying to be awkward, although from a security background, I'm awkward. But devs will say, okay, what is this vulnerability? Why do I need to fix it? I've got enough time in sprint, or whatever segment of time work, in order to release these 4 features. And these 4 features are going to drive this amount of revenue. I'm not going to take time off in order to fix this thing that, frankly, is out in the market working and giving us cash. And besides, if we fix this, I'll take the system down. Do you want the system to be offline for 2 weeks? No, I don't think so. So that's a really interesting conversation to have. And then, how do I fix it? This is great that you highlighted this, but I don't understand why this is broken in the first place. And then you have the conversation with security, which is the other side of the shadow match, which is it really needs to be done, it's incredibly important, the world's going to blow up if we don't do it, and so on and so forth. So throwing it over the wall. So collaboration, making sure these teams are aligned, getting that top-level view of why you're wanting to do application security, why you want to shift left, really super important. Train development teams in secure coding. So today we have with us Fayaba Nafis, who provides great secure coding training for teams. She's up there, we're going to have a chat with her later on. And she can tell you all about it. So sometimes it's not just about, okay, here's how you avoid an SQL injection, or here's how you properly format the code that goes into the system. It can be about what vulnerability means, why does it map to this framework, what does it mean for the production system that's running. We had to run a session with a customer, so we set them up on Molesta. They've got, and the other thing I forgot to mention is typically there's a ratio of security teams to developers that's far outweighed. So they have got one security person and 30 developers. And this one security person runs all security implementation from operational through to application security. So we were brought in to provide a little bit of extra insight into what's ASVS, why is it important, why does it map to certain things, why do we need to take care of it? So it's providing them insights into how the security classification and vulnerabilities work within their particular development process. It's not just a technical thing, it can be a process thing as well. And then getting data out of the system. So everyone's trained up, everyone's aligned, super stoked, we're happy. We now need to identify sensors, get the data out of the system to understand how we're doing from that perspective. And in order to do that, there's a big, long process that you might want to go through. I'm not going to go into it today because this is a whole hour and a half presentation into itself, and we've got a great webinar on this on our YouTube channel. There's a link towards the end of this. But you need to consider things like architecture. So what code are you using? What components that you put together? Are you monolithic? Are you microservices? Do you use a single instance on AWS, or are you fully containerized? These all have impacts on the kind of scaling capabilities that are used. How do you deploy it? What's the risk environment that you work in? So we've already had some chat today about Fintech risk environment, some of the regulatory issues you need to adhere to, think about. And once you start looking into the tools themselves, do you want to go for open source or paid? Because they have a big impact on the kind of utility and usability you can get out of these sorts of systems. And when we start looking at some of these products and some of these tools, the application security product landscape is insane. There are hundreds of tools, and they're all super useful in their own way. But you kind of have to cobble them together to get proper coverage. So this particular slide we're talking about, well, popular commercial tools have got off in certain amounts, with certain open source tools, and then you've got a huge range not being covered because there's always a use case of some form of custom system or custom piece of code that you developed, or maybe a custom business process that's maybe not necessarily mapping to the latest exploitable set of vulnerabilities, but maybe in your particular case. So we were working for an insurance company, and they had basically a process that they needed to check on from one page transition to the other, and we just couldn't find a commercial tool to do it. So they built their own set of custom scripts to check the logic, because it was possible to hijack the section and do interesting stuff with it. And that had to be integrated into the process. And so you now have this kind of looming set of tools you need to kind of wrangle together, get into your pipeline, get all the results out of. Here's another view of some of the different controls that can be mapped into different tools. We've got some open source tools here as well, showing you the kind of coverage that you can get, some of the controls that are commonly found in the marketplace. Great, so I've got all my tools, and it's all running, and I'm really happy with everything. So what do I do next? I'll automate, which sounds really exciting and interesting. So, up until now, we've had lots of developers being able to commit their code. It gets tested automatically, it gets deployed automatically. That's kind of been the net result of the agile movement. That's been Atlassian doing a great job. That's been all of these different kind of movements helping us get to rapid deployment of code. As a security person or DevSecOps person, you don't want to be stuck on a Friday night with a spreadsheet with thousands of different vulnerabilities, half of which you've already fixed or seen before, but because you're running the tools in the manual fashion, you get very little ability to correlate and deduplicate and classify them. So automation is a great sort of end result. But in order to do that, you also need a certain level of maturity as well. And these are kind of the different maturity levels we see across customers, where we've got a traditional kind of manual release process, where typically we've got source code kept on-prem in various legacy systems, all the way through to organizations that have got the ability to click a button, and their stuff is up online within minutes, if not seconds. If you're to the left-hand side, typically you want to work on your systems, your capabilities to get a more agile release process up and running first. There's no point in automating your security testing unless you've got various components stacked together in order to make that work. So once you get this up and running, the automation process, typically some challenges that you can find. So I mentioned sitting around with a spreadsheet on a Friday night. So volume of issues is definitely up there. It can be host plan. Different tools have different tuning capabilities and requirements and needs. If you go in with a stick, for example, if you don't tune it to your environment, and if you don't tune it to what you want to get, you can often get thousands of vulnerabilities off the back of it. You also need a security backlog to go with that in order to understand what you've included, maybe what you've excluded from the decision-making process. Often things can be manual. It's incredibly difficult to automate these things. But this is not just about manual collection of results. It can also be about how you communicate with the development team as well. So Facebook implemented an inline code checking system when they checked the various vulnerabilities. And they basically had a system that would check the code and shift the results off to some system. I think it was a Jira board. And the developers didn't know about it, and as a result, they fixed 0% of the issues that were found. The minute they started showing the vulnerabilities in a system that the engineers looked at on a regular basis, by having that conversation with them, they went from 0 to 70%. So how do you get the engineers the visibility? How do you give them context that they need in order to fix these things? Risk prioritization and metrics. This is a whole presentation into itself, so I'm going to spend approximately 10 seconds on it to give you a great overview. But this is super important and really difficult to do well. How do you prioritize one vulnerability over the other? There are different algorithms out there. So, for example, there's the FAIR Institute. They take into account things like where's the system running, what would it cost to lose medical records or bank details, how many users have access to it, what would it cost to revive the system, put it back up and running, and you kind of mix them all together in order to get a dollar value. However, dollar value is great for certain stakeholders. It scares the bejesus out of security people and developers because they see a $3 billion value to virtual vulnerability. It doesn't really do much, should it? Frankly, it doesn't do much to me either. So it's an interesting one. And then on top of that, how do you track how things are improving? So continuous improvement is the key as well. So we want to see trending down of risk in our portfolio over time. And then finally, things like changing tools. Sometimes you select an initial tool set, spend lots of time integrating into your pipeline, your release process, but you want to put in, maybe you've adopted a new technology, you've maybe heard about a new tool that will give you further coverage or better capabilities. Accessing that release pipeline can be really difficult sometimes because you're disrupting the release capability of your organization. So how do you rapidly change things in and out? So, how do you roll out DevSecOps? So, typically we quite like to suggest you start with small projects, maybe a non-critical application, get a nicely scoped project, select maybe a couple tools, maybe a tool, run it, learn, iterate. So it's a very basic start. So find something small, you're eating the alphabet when it comes to this. So I realise that I'm standing between you lunch, so I'm going to keep it fairly brief. If you'd like to look at any more sort of insights or bits of advice from us, we've got a YouTube channel. Here's some of the webinars and some of the sessions we've got, which kind of go into some more of these questions in far more depth and detail. We've got Gary, who's our co-founder and Chief Information Security Officer. What he doesn't know about AppSec isn't worth knowing. And our head of product, Martin, and some of these as well. So discussing customer use cases, case studies, and giving some key insights. And we've also got a bunch of webinars coming up as well within this year, so it's again covering these topics. So thank you for your time. I'd love to take any questions that you may have. So we work with teams where they have fought doing new things, because whenever you introduce a new thing, it takes time off from doing other things that you're doing already, and everyone's super busy anyway. And so, let's say in the sprint you've got your segregation of different activities. So maybe it's 40% new features, maybe it's 30%. Fixing technical debt, and then maybe it's 30% improvement, training, whatever you want to do. I hope that adds up to 100%, but that's 100% of your time taken up with stuff that's already happening. So finding extra time is really difficult to do. It can be quite a negotiation. And you know, it's kind of like head in the sand time, where if you find problems, you've got to do something about them. Or you could do the thing that one dev team did, which was they implemented the security tool, but they just ignored the results because they turned it down to 0, basically. So they had different tuning levels that they already had, which I thought was really clever. So yeah, it's time. No one wants to do new things, and I totally get it, because again, this is a perfectly reasonable, rational thing for them to be doing. But as a security professional, it kind of horrifies me, but it makes absolute sense in terms of the context of their team, which is why you need to get that cultural buy-in. You need to get it driven from the top so that they can make time to do it. And the business understands that maybe they'll have one less feature per month, or maybe they'll have technical debt addressed in a slightly different way. Have you got another question? I'll see it as a follow-on question.
It's a similar to the question that I did previously. Do you also find it difficult to approach businesses and make them care about their cybersecurity, or it's...
No, I mean, they're usually perfectly aware of it. It's just about timing and projects and time and capacity. So because you need time from the security team and you need time from the development team, it's really difficult finding a gap when they both have the capabilities. And as I said, there's usually fewer security personnel in the company, and so to get their time can be really, really difficult to get on board. Some of the companies we've worked with, they've had big accreditation projects that they've worked on, so maybe they're doing ISO, maybe they've got to get through that first. You know, so there's a set schedule of projects that they're doing before they address this kind of thing. It's not that they don't want to do it, they definitely see the value of implementing application security, but it's a time element. Time is the most precious resource that we have.
When a team is initially set up, would you recommend that they do it themselves internally, or if they have external to come?
Good question. Internally, agree upon why you're doing it and get alignment around what you want to get out of it, but then bring someone in order to help execute on it. So come up with reasons why you want this data, and agree amongst yourselves what you're going to do with it. But you can definitely get an external partner to help you do detailed work, such as CI/CD configuration or tool selection, or we recommend these collaborative tools to allow you to make these decisions faster, or maybe this triage method. So they can fill in some of the details, but definitely have alignment that you're going to do it in the first place amongst yourselves. Hi. depends on the contract you've signed with them. So some of them, I mean, I've seen contracts where it is literally thrown over the wall. We have done precisely what you've asked for. Fayeba's not there because she's been through this recently. Unless you specify every last detail, they're not going to bother with it. So I'd highly recommend from that third-party thing is get that assurance of security around it. The other piece you could do is give them access. And access is kind of quite a nebulous term, but get them to use your internal systems. Maybe you segregate them. Maybe you give them their own Git instance. Maybe they've got a separate release pipeline, if possible. It's quite kind of difficult to do if they're building components that will be integrated into the main kind of branch. But there are ways of architecting it so that they have to adopt your practices, which is, we're not going to pay you until you pass these tests. So traditionally it could be unit tests, but in the contract you can say they need to pass or have a certain level of vulnerabilities that have been detected or changed or whatever, and it's just in the contract that you put together. Usually everything's up for negotiation.